Let's try to solve this problem. Two cars, X and Y, travels along a route in opposite directions. Well, today they provide you a diagram, so I believe you can refer to the diagram. So if car X and car Y, and they are traveling along a road, so they are traveling on the same route, this route, then they are traveling in opposite direction. So X is going towards the right, Y is going towards the left, opposite direction. Okay, at time equals to 0, X is at point O and Y is at point P. So when time is equal to 0, this car is right at this point over here, whereas this car Y is right at this point P over here. Okay, then it mentioned that car X travels with a constant speed of 20 meters per second. That's being labeled over here. The car is moving with speed of 20 meters per second. Y starts from rest and accelerates at 4.0 meter per second squared. So Y was previously at rest at point P, then accelerates at the rate of 4.0 meter per second squared towards the left. Okay, so the distance OP here is 2,400 meter. Okay, so I think this is not a very complete diagram. Yes, it's a good diagram. The car is much nicer than the car that I draw. So, but let's fill up the gaps that we know now. Okay, so it mentions here that at time equals to 0, X is at O, Y is at P. So we should probably expect this car X to be at here initially. This car Y to be initially at here. Okay, then car X move with a constant speed of 20 meters per second. This one is mentioned over here, no problem. Y starts at rest. But the issue is they never mention Y starts at rest in the diagram, so we should label it. So you can say start at rest, so you can say initially is 0 meter per second. I think if you want to avoid any confusion, you can straight away write U. I think it's still a safe choice to write U, but label a big Y. So this is for car Y, the initial velocity is 0 meter per second. Yeah, previously I always encourage not to label anything first, but because there's too many cars here, there's car X, there's car Y, so there's going to be an initial velocity for X, there's going to be an initial velocity for Y. So in this case, to avoid any confusion, maybe we should label it for now. Okay, then it accelerates at 4.0 meter per second square. The distance OP is 2,400 meter. So this one I believe is not in the diagram as well. So let's put it in. So it's from point O to point P here, the distance, not from the car X and car Y distance in the diagram. So from point O to point P, the distance is 2,400 meter. Okay, so they ask, what is the distance of X and Y from O when they pass each other? Okay, so you might be a bit confused. They ask for distance from of X from O, and they ask for distance of Y from O. So they ask two questions, is it? Well, not really. There's only one question to be asked here. The idea is like this: you have car X and car Y, and then opposite direction, right? One is moving in constant velocity, the other one is moving with an acceleration. So at some point, right, they will pass by each other. So X and Y will be on the same point. Okay, X and Y will be overlapping on each other in the diagram. So they're asking for when they overlap each other, right? What is the distance of this point from the point O over here? So X will go towards somewhere here, Y will go towards somewhere here. At some point, they will pass by each other. So they ask for that point, what is the distance from the point O over here. Okay, so that's what we want to determine. So this question is slightly different because it requires a bit more thinking. It's not a straightforward question, but let's think through it. It's not that difficult actually. So you know that car X will start from this point O over here. Car Y will start from this point P over here. So what you know is, if they want to pass by each other, these two cars here have to overlap at some point. So means by X have to be here, Y have to be here. We don't know where is the point, but let's say it's here. Okay, so what is the characteristics? For this point over here, this car X will have to travel a certain distance. Okay, then this car Y will also need to travel a certain distance from point P. Okay, so what is the characteristics of the distance traveled? Well, let's call this point here point Q. Okay, then things will probably be more straightforward now. You see here this distance OQ and this distance QP. If you add them up, it must be equals to 2,400 meter. Because if you want to pass by each other, you must cover this distance, and the rest of the distance will need to be covered by the another car. Okay, so if you add out the distance over here if you add out the distance traveled by car X together with the distance traveled by car Y, you should be able to get 2,400 meter. That's the approach that we should be going when we are solving this problem here. Okay, different situation come in different ways, so the main thing that you need to know is how you should visualize the situation and how should you analyze the situation. Okay, the substitution and the rest are quite easy job actually. The main problem is you have to understand the problem clearly. Okay, so let's write down what we know here. We know that this distance here OQ and this distance here PQ or QP must be equals to 2,400 meter. Okay, so I believe we need to find OQ and we need to find QP in order to solve the problem of finding the distance. Okay, in that case, if we need to find everything, then the distance OQ, this distance OQ here, will be a distance of X and Y from point O. Because distance of X and Y from point O is just OQ. So if you are able to find OQ from this, then we have our answer. Let's now start to solve this problem. So we have car X and car Y involved over here. So let's write car X and write down car Y. Okay, so for car X, we have to determine its initial and final position first. We do step 2, initial and final position. So car X, I'm going to use a blue color. So car X here, the initial will be at this point O over here. So this is initial for car X. So the final for car X will be at this point where they pass each other. So I believe this will be final for car X. Okay, so let's do our SUVAT based on this initial and final position for car X. Okay, so we have capital X for car X, X for capital X for car X, VX, AX, and T. Okay, T should be the same because they start at the same time, they pass by at the same time. So we don't need to differentiate between TX and TY. They both start at the same time, they both meet at the same time. So the duration between start until end is the same for both cars. So you don't need to really specify time X or time Y. But the rest you need. Okay, so let's fill in the blank. For SX, you know that that will be OQ because that is the distance going to be traveled from initial to final position. For UX, VX, we know that it travels at a constant speed of 20 meters per second. So I expect the whole journey should have the same speed. So here you can write 20 meters per second. You can write 20 meters per second. And because you know constant speed means zero acceleration. Okay, and the time is what you don't know. Okay, let's continue to do this for car Y as well. Let's lay down every information that we have. Car Y, I'm going to use green color pen. So it starts initially at point P. So this will be my initial for car Y. Final, I'll be at the point where they pass each other. So this is final for car Y. Okay, so based on the initial and final position, let's determine our SUVAT for car Y. So you have SY, UY, VY, AY, and T. Okay, so let's try to determine for each of them. For SY, you know the distance will be, you can call it PQ, no problem. Okay, because we don't care about direction, right? We just care about the length, so PQ, QP is not a big issue. UY, you know that initially this car Y here is at rest. so 0 meter per second. Final, you don't know because the final velocity of this car Y at this point is not being mentioned here, so leave it as a blank. But you know the acceleration, it is accelerating at 4 meter per second square. So that one you can include it inside here. And the time is what you don't know. Okay, so now if you look at this data, now we will have to figure out what's the correct equation to use to solve the problem. But before we move on further to talk about equation, right, this is something that I mentioned in the notes, but I still haven't mentioned in the video yet. If you see something moving in constant velocity, you see the initial and the final to be having the same speed, right? And you see that the acceleration here is 0. Now you might think of it as having 3 separate information. Okay, like what we usually do last time is we will say we want to find S and we have data on U, V, and A. Then you might think, oh, I have all the things that most of the things that I want. I can use V square equals to U square plus 2AS to find S. Well, that's the issue. If you are having constant speed, right, or constant velocity, right, even though you happens to have 3 data being filled in, right, you can technically only take 2 of them into account. Means by you can only use 2 out of the 3 data that you put in. Because these 3 data here are actually related to each other. So they are not independent data. Usually if U, V, and A, because there's acceleration, you have another final velocity, you have an initial velocity. So these are 3 separate information. But 20 as initial, 20 as final, 0 as acceleration are really 3 very connected information. Initially is 20 meter per second because you have 0 acceleration, therefore you remain at 20 meter per second. So technically it's not considered three separate information. You can think of it as 2 only. So you have to actually remove one of them. If you're not sure what I'm saying, right, probably you should review the notes here. But I'm going to remove A over here. Means I treat myself having 2 information and I have 1 information that I want to find. Okay, I have to remove one of them because these 3 are interconnected information. They are not independent information. So you have to remove one of them because yeah, it's not 3 information. It's because you know 20 as initial, acceleration is 0, therefore you know final is 20. It's not that there are 3 independent information. Okay, so this one you can think of it as not enough information because you have only 2 information that you know and 1 information you want to determine. Usually it's 3 information that we know, 1 thing that we want to determine, right? But now it's not enough information. But let's see how we solve if we have not enough information. Okay, let's continue. For car Y, you have 1 information, 2 information, and the things that you want to determine is the displacement. So again, you have not enough information. So how do you deal with the situation where you have not enough information? See how many objects is involved here. Here you have 2 objects here. You have car 1 and car 2. So when you have 2 objects and you have not enough information, you should straight away think of simultaneous equation. Means by you have to include another things that you don't know. In this case, we are going to include time and other things that we don't know, and we are going to use simultaneous equation to solve it. Okay, let me show how. So now you have S, U, V, and T. We are going to use the equation Sx equals to half Ux plus Vx T. Okay, we are going to use this equation even though this equation has 2 things that we don't know. We don't know Sx, we don't know T, we know U, we know V. Even though we have 2 things that we don't know, but we are going to use this equation because the car Y equation also have 2 things that we don't know, which is the S and the T. Then later we can do simultaneous equation, then combine them to find either the distance or the time. Okay, so let me continue substitution. So this one I call it OQ, and this one is half U plus V is 20 plus 20. Then the time is, I don't know. So now if you add up everything, divide by 2, you get 20 T. So this is OQ. and you leave it like this. Okay, not solved yet, but you leave it like this, never mind. Let's move on to car Y. Car Y, you are going to include S, U, A, and T. If you include S, U, A, and T, what equation you should use is, you should use Sy equals to Uy T plus half Ay T squared. Okay, so this is the equation that you use. So substitution, Sy is PQ, Uy is 0, so you can put 0 for everything, plus half Ay is 4, then you have T squared. So now you know that PQ is equals to T squared. Okay, not solved yet, but never mind, because you know now you are left with one unknown, and you can bring this insight into our equation over here. Okay, so let's do that. OQ plus QP equals to 2,400 meter. But you know that OQ is 20 times T plus, this one is 2T squared. Okay, so plus 2T squared, then it's equals to 2,400. Now if you solve for T, I believe you get two answers, but I'm going to write down the positive answer only, which is 30 seconds. Okay, you have another answer, you can cross it out and say you reject the answer. Okay, so once you have got your T, it's not the end yet, because this is the time where they pass each other. But we are not interested with the time, we are interested with the distance of xy from O. So it means we have to find this distance OQ here. So we have to substitute it into this OQ over here to find the distance OQ. So let's do that. OQ here is equals to 20 times time. And since we know time is 30, so we can take 20 times 30. Then you get your answer of OQ to be 600 meter. And that is our answer over here. The distance of X and Y from O is 600 meter. So you can write it down because we use symbol that is not previously mentioned in the diagram. So it's better that we write it down again. Distance of X and Y from O is 600 meter. And that is how you solve this question here. Again, the main point of showing you this question is if you have two objects and you have not enough information for both objects, what you can do is you can involve them in a simultaneous equation. Pick another unknown that you don't know, combine it with the so you get two unknown and two known value. Then you can build your equation, and from there you do your simultaneous equation in order to obtain your answer. Again, the key to solve this problem is to realize that OP plus QP equals to 2,400 meter. So that one requires experience and practice. You practice more, you are able to catch what is the key approach to a problem. Okay, and that sums up our how to solve this problem over here.